Welcome to Brain Vision.
Okay, so we're doing chapter 37, problem 54. So it says for three hydrogen transitions indicated below, with N being the initial state and N prime being the final state, is the transition an absorption or an emission? Which is the higher initial state energy or the final state energy? And which of these transitions involves the largest energy? Photon. Okay. So to start out, we should know that the energy of a level N is given in the Bohr model is given by the negative Rydberg constant 13.6 eV over N squared. So for part A, it says N equals 1 to an N prime of 3. Well, based on this equation here, we should see that higher energy levels are going to have higher energies because of this negative sign, right? So you'd think it was the other way around because N squared is on bottom, greater N squared means a lower number, but since it's negative, that's actually a higher energy. So if N prime is our higher state, then we know this is absorption because we're going from a lower energy to a higher energy. So now we can find the photon energy, which is just the energy difference between these. So energy of the photon is just energy of level 3 minus energy of level 1. Well, let's write that out. That's negative 13.6 eV times 1 over 3 squared minus 1 over 1 squared. And this comes out to being 12.1 eV for the energy of the photon. Okay. Part B. Part B says N equals 6, and we're going to an N prime of 2. Well, we already said that the higher the N value is, the higher the energy is. So we know that N equals 6 is higher, and then we're going to a lower energy. So this must be emission. We can then write the energy of the photon as the energy difference here. So energy of 2 minus the energy level of 6. And since we can't have a negative energy level of our photon, this is just the absolute value of the difference, or how we can also do it is we know we just add another negative sign for emissions to get a positive energy at the end. So this becomes 13.6 eV, and then we have 1 over 2 squared minus 1 over 6 squared. What does that give us? Well, it gives us 3.0 electron volts. Okay, part C says N equals 4, and we're moving to N prime of 5. Again, we see N prime is bigger, so it's a higher energy level, so this leads us to absorption. And we have energy of the photon is given by E5 minus E4, or negative 13.6 eV, 1 over 5 squared minus 1 over 4 squared. And this one comes out to being even smaller energies of 0.31 electron volts. So that means the first one, or case A, has our highest energy photon for the transition.